So welcome to the 6th week of this NPTEL lecture online sessions. So today I'll be covering topics matrices and eigenvalue problems and rotation matrices in 2D and 3-dimensional case. So basically these two topics have already covered in phase 1, but many of you are not there in phase 1, so I thought that today I'll be covering this section. Matrices and eigenvalue problem. I will solving gate questions, only 5 to 6 gate questions, and which will cover these two topics broadly. And many of you must already be familiar with these two things, but still, it's good to go through this. And so the first question which will be solving today is the question appeared in gate 2020, question number 26. So the question was that they have been given some 3x3 square matrix. Okay, and then they have asked that what is the product of the eigenvalues. So whenever you have this, excuse me, okay, is it breaking? Hello, hello.
No, sir,
Hello.
it's fine.
Okay, so is it now fine or still breaking?
Yes, sir, it's fine.
Okay. Okay, some people have already answered it. I know, but there is a lot of tricks to find the question answer to it. But I will just start with some basics. So first of all, before going into tricks how to solve this question in GATE exam, I will just give a little background of from where these problems originate. So whenever you have this kind of eigenvalue problems, the first thing which you should remember in your mind, it will help in your interviews, is that they have their origin with this problem, with this equation. This is just the eigenvalue equation which you must be knowing. So what does this eigenvalue equation represents? So first of all, what are these terms? So here in matrix notation, this X is nothing but it is some n cross 1 column vector. This n cross n column vector represent any vector in 3 dimension, or for here it is 3 cross 3k, so it is any vector in 3 dimension, like having 3 components in 3 directions. Then A is some n cross n square matrix. It is some operator which operates on this column vector space. Lambda here is some scalar quantity, and X is already this n cross m column vector. So this actually is a kind of eigenvalue equation, is nothing but is a linear transformation, kind of linear transformation. This equation where your A is some linear transformation operator. It can be in matrix form or it can be in some another form also. Here it is in matrix form. Linear transformation operator. Lambda is some already said some scalar. So what is happening is that this operation of A, this A is operating on X, that is this linear operator is operating on X, and it is scaling the X with some value lambda. So the operation of this A and X is nothing but it's just scaling the vector X with some constant value lambda. So it is so this kind of equation, this kind of linear transformation comes into special class, which are known as can be represented by this eigenvalue equation. And this lambda are called eigenvalues. Okay, so for example, this operation, this A can be anything. It can be some differential operator like d by dx, or it can be some other thing like we will study later in today's class. It can be some kind of matrix like rotation matrix or anything. These are some few examples of what is this A, and X is some vector in some vector space. So from this eigenvalue equation, how do we come to solve, like if we have this eigenvalue equation? So we can also write it in this form, where I is your identity matrix 3 cross 3. So you must be knowing I is some identity matrix. Now, in order to solve this question, let us multiply both sides with A minus lambda inverse. This will be 0 only. Now you know that if A minus lambda I is invertible, invertible means that A minus lambda I inverse exists. In that case, your quantity A minus lambda I times A minus lambda inverse is not equal to 0. It is some value. For example, if you just consider it some D, then it will be D inverse. And then you know that this is some identity matrix, TD inverse. So it is not equal to 0. So in that case, if you look at this is not equal to 0, so only X is left. So X is equal to 0. So for invertible, A minus lambda is invertible. In that case, only X is 0, which means that this is a trivial solution of, this is called trivial solution, which is, but we do not require trivial solution because it is just obvious from this that X is equal to 0 will mean that this equation is satisfied. So in order to have non-trivial solutions, the condition is that your matrix A minus lambda I should be non-invertible, and the condition for that is, for condition of that is that determinant of A minus lambda I should be 0. So this is the condition for the non-invertible case. In order to have non-invertible matrix, the determinant should be equal to 0. So from here we can see that from how eigenvalue equation we come to this equation, which we need to find, which we generally use to find the eigenvalues of any matrix. And this is called the characteristic equation. Generally we call this as characteristic equation. Just wait a minute. Okay, yeah, this is called characteristic equation, and we solve this characteristic equation to find the answer. So for example, in this question, we have been given this is the matrix, so we need to find its eigenvalue so that we can find the product of the eigenvalues. So I will just quickly do this, because 0 0 1 0 1 0 0 0 1 0 1 0 1 0 0 minus lambda times I is 3 cross 3 identity matrix, so I'll just multiply this. So this is what you're left with. A minus lambda I, A is 0 0 1 0 1 0 1 0 0, and then you just solve this. So you'll get what? Minus lambda 0 1. Please tell if I'm writing something wrong. So 0, this will be I think 1 minus lambda, this is 0, this is 1 0. Am I right? Hello?
Yes, sir.
Okay, so you just find the determinant of it equal to 0. So you just find the determinant, what you'll get, minus lambda 1 minus lambda times minus lambda plus 0 plus 1 times. Okay. Wait, if I'm not wrong. 1, yeah, plus 1 times 0 plus lambda minus 1, something like this. So minus lambda, this will be what, minus will come out, so no, yeah, minus will come out for this. So it will lambda square, oh sorry, so it will lambda square 1 minus lambda minus 1 minus lambda is equal to 0. So just solve 1 minus lambda, you take common, so you're left with lambda square minus 1 is equal to 0. So you have lambda is equal to 1, 1 minus 1. I think these three are the eigenvalues and solve this equation. First will give lambda is equal to 1 and this will give lambda is equal to plus minus 1. So in this way you got three eigenvalues because it's 3 cross 3 matrix, so it will have three eigenvalues, and corresponding to the product of this eigenvalue is what is just minus 1. So option A is correct, but this is a little lengthy method. You do not need to use this method to solve question, but just background. So the couple of properties is very handy properties to know that the trace of suppose you have some matrix A, then trace of that matrix A, suppose the matrix is A, which is nothing but the sum of the diagonal elements, is equal to sum of the eigenvalues of that matrix. So the eigenvalues of the matrix. So, and the second property is the determinant of that matrix is equal to the product of the eigenvalues of the matrix. So in our case, matrix is, suppose matrix is this 0 0 1 0 1 0 1 0 0. Then its trace is what? Trace is sum of the diagonal elements, which is 0 plus 1 plus 0, which is equal to 1, and this is equal to nothing but the sum of the eigenvalues. So it is 3 cross 3 matrix, so it will have 3 eigenvalues. So let us say it is lambda 1 plus lambda 2 plus lambda 3. Okay, and the second property is that the product, if you find the determinant of the A, because we in the question they have asked product of the eigenvalue, so we can just straight we can just use this property and find the determinant of A, which is nothing but if you find 0 minus 0 plus 1, and it will be minus 1. So if directly you find the determinant of this matrix A, you will get minus 1, which is the product. So in shortcut way, you can just find the product of the eigenvalues without going into details of the eigenvalue equation all. So you just need to find the product of the eigenvalues. So it will nothing is just the determinant of the matrix. So is it clear?
Yes, sir.
Okay, thank you. Now the next question is the question 2013 gate question number 42. It is an NAT type question. So you have to solve and provide the answer in the form of number. So the question is the degenerate eigenvalue of the matrix. So it is simple, like you can just solve the determinant A minus lambda I 0. You find it is 3 cross 3 matrix. You will find three eigenvalues. Suppose lambda 1, lambda 2, and lambda 3. Out of these three eigenvalues, what does this word degenerate actually means? So suppose you got this 3 cross 3 matrix. So you'll solve this, you'll get three eigenvalues. And also you get three eigenvectors. Corresponding to each eigenvalue, you can get three eigenvectors. Now, if more than two eigenvector has same eigenvalue, then in that case that eigenvalue is called degenerate. So what it means is that what you do is that you just find the solution, you just find the eigenvalues and see if any two of the eigenvalues are same. If they are same, that means that they are degenerate. That is, it is occurring twice. So you just have to, you don't have to follow the lengthy process like following this. You can just apply first two properties. You first suppose that the eigenvalue is a lambda 1 plus lambda 2 and lambda 3. So you just find the trace of the matrix, which is the sum of the diagonal elements. So lambda 1 plus lambda 2 plus lambda 3, that is trace of the matrix, is the sum of the, nothing, it is 12. So this is equation 1. And then the product of the eigenvalues is nothing but the determinant of the matrix. So if you just find the determinant of the matrix, it will be 4 times 16 minus 1 plus 1 minus 4 minus 1 minus 1 1 plus 4. So 4 times 15 minus 5 minus 5, 60 minus 10, so it is 50. So the product of the eigenvalues is 50 and the sum of the eigenvalues is 12. So how to solve it? Just use some trick, you just factorize it, so you'll get, okay, so 5 cross 5 cross 2 is 50 and 5 plus 5 plus 2 is also 12. So that is true that the eigenvalues of this matrix is what? Nothing but 5, 5, 2. Because if you just sum this thing, you will get the 12 and the product of this is also equal to 50. And so you know that the eigenvalues are nothing but 2, 5, 5, and 5 is repeating. So it corresponds to two different eigenstates. So the answer for this question is simply the degenerate eigenvalue is 5. So that's it. So I think most of the questions which when it comes related to this finding eigenvalues, it can be solved by using these two properties. Is it clear?
Yes, sir.
Yeah. No, I think this question based on last two questions you can easily solve. So I would just want you to answer this. So they have given some matrix and they have asked you what are the eigenvalue of this matrix. So out of 4 options, you can just tell me.
B.
Option B. Okay. Anyone else? So everyone else agree that it is B, or someone has some other answers as well. Any other answer? Mm, I don't see anyone. So hello.
Yes, sir.
Okay, B. Yeah. So yeah. So yeah. So as you said, as you can see that you can easily find out that the diagonal elements are 0. So the sum of the eigenvalues should equal to 0. Now to these 4 options, only option B has this root 2 minus root 2 plus 0 0. So only option B satisfied. So this kind of question can be solved in just seconds if you know the properties. So no need to go into details. An aggregate question, this kind of question comes at like where you do not where you have to use some shortcuts. Okay, so I won't solve this question. You already answered it. Now, what I will do is that I will solve a couple of questions related to rotation metrics. So here, the question appeared in GATE 2019. I also gave the exam in 2019 only, so I remember this question. So the question is that during a rotation, vectors along the axis of rotation remain unchanged. So for a given rotation matrix, the unit vector along the axis of rotation is what? So you need to understand this question. There are a couple of things. First of all, what is, yeah. So first of all, Chaudhary has already answered it, but I will solve it. So what is rotation? So it is also kind of linear transformation. So suppose you have some in two dimensions. Suppose you have some vector which is lying on this direction v theta along this x-axis, and suppose you have some rotation and this axis, and you transform this coordinate system from xy to a new coordinate system, or you rotate this by theta. Okay, so you rotate the axis by some angle theta. So what would be the in the new coordinate system, what would be the value of this vector, original vector v theta? So it is transformed from v theta dash. So this kind of operation is also comes in a linear transformation. So there is some linear transformation matrix T which is acting on some vector v theta, and it's rotating it to another vector, another coordinate system where the value of v theta is nothing but v theta dash. So you need to find v theta dash. And what is this T? So T is this kind of transformation is accomplished by this rotation matrix. Let us represent it by r theta. So these rotation matrices are in 2 dimension. You can remember that r theta is nothing but cos theta minus sine theta cos theta, where theta is taken positive in anti-clockwise direction. So this is very important because in sometime question they say that the axis rotate in clockwise direction. In that case, you have to take into account minus sign. So theta is positive in anti-clockwise direction. Okay, so in 2 dimension case, this is the rotation matrix. So when this, you just apply this rotation matrix to original vector, and then you will get a transform vector, where theta is some angle, let it be 30 degree, 50 degree, something like that. So here in this question, and some of the properties of this rotation matrix are, first property is that they are square matrix. Number of rows and number of columns are same, n cross n, something like that. They are orthogonal. Orthogonal R transpose is 1 or entity matrix, and then their determinant are always equal to plus minus 1, unity. So a unity determinant. So these are some of the properties which you can use to find that whether a given, suppose in the question they just give some format options and they ask you that which one of these are rotation matrix. So you can just use the 3 properties and you can just find that okay, this one is. So in this question they have given 3 dimensional rotation matrix and they have already given the values. So it's some so basically what they're asking is that in this question that during a rotation there is some vectors which lies along the axis of rotation and they remain unchanged. So during a rotation, that means a rotation matrix is acting on some vector. So this kind of transformation we know. In the question they are saying that during some rotation the vectors along the axis of rotation remains unchanged. That is, we are getting the same vectors. The vectors are remaining unchanged. There is no change in the vectors even after rotation. And these vectors, let us say that these vectors are represented by v theta and they lie along the axis of rotation. So along the axis of rotation, it means that suppose in 2 dimensional case, this vector is lying along this axis of rotation and this axis rotate along this axis by theta. So similarly, in our case also, suppose these vectors which lies along the axis of rotation are A, B, C. Any vector in 3 dimensional case it can be represented by a column vector. So this thing should also be kept in mind. So you can represent that vector along the axis of rotation by a column matrix A, B, C, and then you just operate this 0, 1, 0. This rotation matrix is acting on this column vector 0, 0, minus 1, minus 1, 0, 0 is operating on this vector and is giving the original vector only. There is no change on the vector in the even after the rotation. So what is the value of ABC which you need to find? They've asked what is the value of ABC? What is the value of this vector along the axis of rotation? So now it's just 3 equations. Just solve this. So first equation is A times 0 B is equal to A. Second is minus C is equal to A. So combining these two, you will get what? A is equal to B is equal to minus C. So I've just multiplied this side. So I've got 2 equations. First, by solving this into this, I got D is equal to A, and by solving this into this, I got minus C is equal to B. If I'm not wrong, yeah, minus C is equal to B. So you've got, and combining these 2 equations, you got A is equal to B is equal to minus C. Now suppose C is minus 1, you can just assume in that case your B is nothing but minus of C, which is 1. So your matrix, your vectors will be what? 1, 1, minus 1. So these are the vectors which lie along the axis of rotation, but they have asked unit vectors which lie along the axis of rotation. So you just have to normalize this. So unit vectors are nothing but Suppose you just by the magnitude. So 1 1 minus 1, and its mod is amplitude will be nothing but just square of the each element. So 1 plus 1 plus 1 and root. So it will become 1 by root 3. Okay, so this is the unit vector which lies along this axis rotation, or you can just write this as in vector notation form. You can just write this as I plus j minus k. So option B, option B is the correct option for this question. So is it clear?
No, sir.
To whom is not clear?
Harish.
Yarish, what did not understand?
सर लास्ट में आपने ए बी सी की वैल्यू कैसे निकाल दी?
No, you have three equations. A, B. You have this equation A is equal to B is equal to minus C. Okay.
सर कैसे आया ए इक्वल टू बी इक्वल टू माइनस सी?
You just multiply यहाँ तक समझ में आ गया this equation?
यहाँ तक समझ में आ गया सर. इसके आगे
you just do matrix multiplication. 0 times A plus 1 time B plus 0 times C. So it is B is equal to what? First element of this column matrix. This is 3 cross 3 matrix. This is what?
यस सर.
आया सुनना?
हाँ.
So you have to multiply this, and then similarly when you will solve the second, then you will get 0 times 8 plus 0 times b minus 1 times c is equal to b. Then I just combine, since a is equal to b and b is equal to minus c, then we just combine these two to get a is equal to b is equal to minus c. So this is how you just need to solve this. Okay, so now this is clear. So now I will just ask you people to solve this. Okay, before that I would just, so here in this question is also related to matrix rotation only. So here they have asked that consider there's a vector p in some coordinate system. It has this value, and then the axes are rotated anti-clockwise about the y-axis. Now since it's a three-dimensional vector, and so you have to take into account that rotation is taking place along which axis, like x, y, z. So about which axis the rotation is being carried out. So here they're saying the rotation is carried out about this y-axis. So I will just give you three matrices like rotation matrix. So in three-dimensional case, if the rotation is carried along the x-axis, then the rotation matrix is this. If the rotation is carried out along the y-axis, like if you're trying to rotate the axis along the y-axis, then the rotation matrix is this: cos theta, 0 sine theta, 0 1 0, minus sine theta, 0 cos theta. Similarly, if the rotation is carried along the z-axis, then you have this rotation matrix. Now in this question, they are saying the axes are rotated about y-axis. So what they are telling is that you are having some linear operations where this rotation matrix y is acting on some vector p, and it gives another vector p dash, which represents this vector in some new coordinate system. This is old coordinate system, and after getting rotated along about the y-axis, what is the value of this p vector in this new coordinate system? So simple, you just apply this equation. Here ry is nothing but cos theta 0 sine theta 0 1 0 minus sine theta 0 cos theta. P is your original vector, which is 2 3 2 2 3 2. It has three components. In x direction it is 2, in y 3, and k 2. So then what is the value of, say, p1 dash, p2 dash, p3 dash, or px dash, py dash, pz? That is a new coordinate system. What is the value? So theta is 60 degree, anti-clockwise, so positive only, theta is positive. Now you just suppose if the question they have must they if they would have given the axis are rotated clockwise, then you would have taken theta is equal to minus 60 for clockwise case. But since the rotation is anti-clockwise, so you'll just take plus 60 degree. This is convention. Okay, so you just cos 60 is what? Cos 60 is 1 by 2 0, sine 60 is root 3 by 2 0 1 0, minus sine 60 is minus root 3 by 2, cos 60 is 1 by 2. Now just do matrix multiplication. So what you'll get? First you'll get 1 by 2 times 2, which is 1, plus 0 plus root 3 by 2 times 2. So 1 plus root 3. Second is simple, 0, it will be 3. And the third component is minus root 3 by 2 times 2, which is minus root 3, plus 0 times 3, plus 1 by 2 times 2, which is 1. So these are the three components of the matrix in the new coordinate system. So in vector notation, you can just write this as p dash is nothing but vector p is nothing but 1 plus root 3 I cap plus 3j cap minus plus 1 minus 1 plus root 3 I cap plus 3j cap plus 1 minus root 3 k cap. So you just have to provide these three values, 1 plus root 3, 3 and 1 minus root 3 in the option. So in this way, you just, if suppose the question, it was given that the rotation is about the z-axis, then you would have operated this matrix cos. And if the rotation was about x-axis, then you would have used this matrix. So there are three classes of matrix which you need to remember in order to solve this kind of question. So, clear this?
Yes, sir.
Okay.
Sir, can you very briefly tell us how to remember this matrices, rotation matrices, or how do they come actually?
In order to remember, you just, if you remember in two dimension, like in two dimension,
सर
you
मैं
can see, hello,
सर मैट्रिक्स शो करना आप एक बार
क्या?
मैट्रिक्स शो करना आर एक्स आर वाई और आर जेड
Yes, yes, they only matrix only. So I think that can be from one coordinate system to another coordinate system if you are doing some transformation. So you just need to remember. I think I will cover that because if you rotate, suppose this cos theta, then in other dimension and in another coordinate system, you'll just take the component. You will just project. I don't have the derivation of that right now, and I also don't remember
सर
how. Yeah.
एक्सक्यूज मी सर
Yes. Yes.
सर ये बिल्कुल वैसे है ना जैसे पाउली मैट्रिक्स में हम करते हैं रोटेशन
Okay, polymatrices you are talking about. Yes, yes. The concept is same there also. मतलब
सर एक
what?
बार मैट्रिक्स शो कर दो आप आर एक्स आर वाई और आर जेड मुझे लिखना
Hmm. What Rx, Ry, Rz? What?
ये वाला सर थैंक यू ये वाला
Mm-hmm.
सर एक बार लिख लेता हूँ इनको
Okay, but I've already shared this. I've already shared this slide. You don't have this access to this PPT.
Done, sir.
Hmm. Okay, so someone asked that how we can get this. You just what I would suggest is that you just try to do transformation from one coordinate system to another coordinate system. So right now I won't do this, but I can do this in next class when I will be doing that thing. I will also cover one lecture which I missed from Cartesian coordinate to spherical polar coordinates, those kind of transformation and everything. So from when I will do that class, then it will become much clearer that how you get this.
Okay, sir.
Hmm. Now this question is very straightforward for physics people because in quantum mechanics you already studied that the eigenvalue values of a Hermitian matrix is what. So most of you understand that since they represent some physical quantity, so and physical quantity cannot be imaginary, so the and hence the eigenvalues of the Hermitian matrix is always real. Eigenvalues of Hermitian matrix are always real because they represent some physical quantities. How to prove this? So basically, first, what are Hermitian matrix? So in order to understand a Hermitian matrix, suppose you have some matrix A, and you just do the complex conjugate of it and take transpose. So this is the Hermitian matrix. And if you do this and if you get the original matrix A, then the matrix is said to be Hermitian. For example, let us suppose we have some matrix, two-dimensional matrix, 3, 2 minus I, 2 plus iota, and then 4. Now what you do is you just take the complex conjugate of it. So do nothing but 2 plus, you understand complex conjugate, you just replace imaginary sign with its counter conjugate. So, and now you just take the transpose of it. It will be what? Transpose means you just replace columns with columns, rows. So 3, 2 minus I will become this, and 2 plus I out of 4. So A transpose T is nothing but, and this is nothing but the original matrix A. 3, 2 minus I, 2 plus I, 4. So if all those matrices which satisfy this equation are called Hermitian matrix. Some of the properties of this Hermitian matrix are that already said they represent some physical quantity. Then their eigenvalues are always real, hence eigenvalues are always real. Like in one of my interview in PRL, they asked me to prove this. PRL in one of the interview in Physical Research Laboratory Ahmedabad, they asked me to prove mathematically that why the eigenvalues are real. So I will just show you. So this kind of question comes, and also the third property is transpose is they are orthogonal, so they satisfy this property. So they asked me that how you can show mathematically that eigenvalues of Hermitian matrix are real. So in order to show that, you just have to assume that there is a matrix A.
Sir,
Hello, yes.
is the third property true for Hermitian conjugate? Hermitian matrix.
What? I didn't understand what.
the third property that you write, actually I lost my connection, so I was asking that the third property that you wrote is actually you have written this for Hermitian operator.
It can be this, right? This is this. So yeah, so let me clarify it. So yeah, this is true for Hermitian matrices, and in the case if the matrix has complex part, then we write it in this form: a theta a is equal to I. Because if the matrix has only real part, then this conjugate part just goes away and you're just left with A transpose AI. Is it clear what I want to say? Like, these two are actually same. These two properties are kind of same, not same, but they're actually same. They just represent two different class. Like here I've represented in the form of Hermitian matrix because A theta is nothing but AH. Suppose you have some matrix A, so its Hermitian is represented by AH. So yeah, for Hermitian matrix, this property is true. A transpose A is I.
सर इसकी आइगन वैल्यू नेगेटिव भी हो सकती है ना?
Yes, its eigenvalue can be negative, but it should be real. It should not be complex. Complex नहीं. So let us assume that we have some matrix A and it is Hermitian, that is A is equal to A theta. So let us assume this. Now we'll write the eigenvalue equation. This matrix is acting on some vector x and it's giving lambda and x. So this is eigenvalue equation. Now you just take the Hermitian on both sides. So this you can just write it as x theta, a theta, lambda theta, x theta. The theta just represent the Hermitian of any matrix. So since we have assumed that a is equal to a theta, so this will become just x times a. And lambda is scalar, so its Hermitian conjugate is nothing but it's just a scalar. So we can just write it this form, and x theta. Now just multiply both sides by x. So x theta ax is equal to lambda. You have just multiplied both sides with x. Now by using the eigenvalue equation, ax is nothing but lambda times of x. So it will become lambda times x theta x. Since lambda is some scalar, we can just write it in this form: lambda x theta x is equal to lambda var x theta x. Now we just take uh, x theta x common. So left with lambda minus bar is equal to 0. So I've just taken this on this side. And we know that this is not equal to 0, one of the property of the Hermitian matrix. So this cannot be equal to 0. And so we are only left with this lambda minus lambda bar is equal to 0, which means that lambda is equal to lambda bar. And this holds true only for real values of lambda. Because if lambda is some complex, for example, lambda is some 2 plus iota, then lambda bar will be 2 minus iota, so which are not equal to each other. But if lambda is real, so, and hence this proves that lambda is real, it's not complex, and hence the assumption which we assume initially is that this is Hermitian. So for Hermitian matrix, the lambda is always real. So this way, mathematically you can prove that for Hermitian matrix, lambda is always real.
Sir, that means every Hermitian matrix is also unitary according to the property number 3.
Hermitian matrix are also unitary. Yeah, it seems like, right?
Sir, always.
I'm not pretty
Real
sure.
real Hermitian matrix is unitary.
Yeah, so real Hermitian matrix. Yeah, that was what I was trying to say with these two
Actually,
properties.
not unitary, orthogonal.
Orthogonal. Unitary matrix has some other properties, right?
Yes,
So
that would
real
be U dagger U equals to identity. That would be the
Hmm.
property of a unitary matrix.
Mm-hmm.
Okay.
Very,
real Hermitian should be symmetric, not orthogonal or unitary.
which matrix?
Real Hermitian should be symmetric.
Okay. Okay. Yeah, that might be true. So you study that in quantum, right?
Yes, sir.
Mm-hmm. Yeah. So I think this is clear, right? This question.
Yes, sir.
Okay. Yeah. So yeah. So these are like four to five questions related to matrix problem, which came in GATE exam and solved it. So I think it's clear to all of you how to solve these kind of questions. So yeah, for example, here they have given form high Hermitian matrix. So you should also know that suppose you can just change unitary matrix, or you can just give some another classes of matrix, and they can just ask you how the eigenvalues of those matrices are. So you can just practice all those other cases as well. Okay, and okay, so next class I will for today's class I have this only. Next class I'll be starting complex analysis.
Sir, please share your mail ID.
Mail ID is you have sent some link. I don't know what is. Okay, so in that case we'll meet next. And so I also want to wish you happy new year. So, so all the best to you for your
Happy New Year, sir.
yeah happy.
Happy New Year, sir.
Mm. You can take 1 2 day break and then you can again start preparing because are the dates out? When is the GATE exam?
Yes, sir. Probably 11th or 12th Feb.
11th or 12th Feb. Okay. Yeah, so I will just advise that I think most of you must have covered the syllabus. So I would just, and also, yeah, one more thing I wanted to tell you. Just give me 20 seconds. There is some announcement. Okay, so yeah, so and I think the NPTEL people have asked us to inform you that there is some GATE mock test which is being conducted in GATE portal every Sunday from 2 to 5 p.m. Okay, so tomorrow is Sunday, so you can just all the people who have registered on the GATE portal, they can just give this mock test. So it takes place every Sunday from 2 to 5 p.m. Okay.
Yes, sir.